Unit 6, Part 1 review. We've got people that own an Xbox and a PlayStation. People who would own an Xbox would be everyone in that circle. Doc, Grumpy, Happy, Sleepy, Sneezy. All those people own an Xbox. All the people that own a PlayStation would be Bashful, Sleepy, Sneezy. All those people own a PlayStation. Sleepy and Sneezy would own both of them. They'd own an Xbox and a PlayStation. And Dopey owns neither one of them. So, number one, find A intersect B. This means A and B. That means the people that own an Xbox and a PlayStation. Okay, set A is the kids with an Xbox, B is with a PlayStation. Find A and B. So we're gonna say the people that own an Xbox and a PlayStation are Sleepy and Sneezy. Okay. Number two, find A union B. This would be A or B. So, does Doc own an Xbox or a PlayStation? Yeah, he's got an Xbox. Does Sleepy own an Xbox or a PlayStation? Yeah, Sleepy's got both of them. Does Bashful own an Xbox or a PlayStation? Yeah, got a PlayStation. Does Dopey own an Xbox or a PlayStation? No. So we're going to write all the names except for Dopey right here. Okay. Last one, this apostrophe right here is called the complement. Complement is a fancy word for not. So not in A. That means the people who don't own an Xbox. People that don't own an Xbox. Does Doc own an Xbox? Yep. Not going to write those people. Does Sleepy own an Xbox? Yeah. Not going to write those people. So Bashful and Dopey, I think, are the only ones that don't have an Xbox here. Okay. Last two down here. The set A intersect B. We've already talked about this. Let's write this in words though. This represents the people who own an Xbox and a PlayStation. Okay. This U wouldn't mean and, it would mean or. So I've got the people who own an Xbox or a PlayStation. Next, we're going to slide up here. All right, we got three of them. Let set A be the names of kids who watch Breaking Bad. So this would be set A. B, the name of kids who watch Sesame Street. Sesame Street right here is B. C, name of kids who watch Walking Dead. C right there. So it looks like Mitchell and Michaela don't watch those three television shows. All right, so I've got B intersect C. I need the students who watch Sesame Street and Walking Dead. Who watches Sesame Street and Walking Dead? Michelle and Mike. Those two watch Sesame Street and Walking Dead. Okay. Next one, number 7. We've got A union B. This would be the people that watch Breaking Bad or Sesame Street. So let's look up here. Does Maggie watch Breaking Bad or Sesame Street? Yeah, she watches Breaking Bad. Mark, does he watch Breaking Bad or Sesame Street? Yeah, he watches both of them. Melinda, does she watch Breaking Bad or Sesame Street? Yeah, she watches Sesame Street. What about Mike? Does he watch Breaking Bad or Sesame Street? Yeah, he watches Sesame Street. What about Matt and Molly down here? Do they watch Breaking Bad or Sesame Street? No, they just watch Walking Dead. Okay, so A union B would be Maggie, Megan, Mark, Macy, Michelle, Melinda, and Mike. I think that was everybody. So people who watch Breaking Bad or Sesame Street: Maggie, Megan, Mark, Macy, Michelle, Melinda, and Mike. Everything in those two circles. All right, last one right here. We've got the complement of A union B. So everything that's not in A union B. We just did A union B. These would be the people that don't watch Breaking Bad or Sesame Street. Well, who doesn't watch either one of them? Well, these people up here watch Breaking Bad or Sesame Street. Matt and Molly don't watch Breaking Bad or Sesame Street. Neither do Mitchell or Michaela. So we're going to write those 4 names down. Okay, we got another set down here. In soccer, a shutout is a game where the winning team does not allow the other team to score a goal. That's pretty much in every sport ever created. A shutout, when the other team doesn't score a goal. If W represents wins and S represents shutouts, which set describes the set of wins or shutouts? Well, we know or, that means the U, okay? So we're gonna say wins, U, shutouts. I think it's B. Okay, next one, in soccer, same kind of deal. If set W is wins, S is shutouts. Wins and shutouts, that's going to be the intersection, the upside down U. So W, upside down U, S. I think it's going to be this one. So what would the other ones mean? Okay, so this would be not wins and not shutouts. So I guess not wins would mean like losses or ties and the other team scored a goal. Okay, this would mean losses or ties or the other team scored a goal. So not shutouts. Let's slide down. Number 11. Which two-way frequency table, there should be a hyphen right there, shows that X, what does this line mean right here? Gold star if you got it right. This means given. Okay. So which two-way frequency table shows that X given Z is equal to 0.48. Well, we did all those given problems yesterday or the day before. And when we see the word given, we circle that column or we circle that row. So when I say X given Z, I have event Z right here. I'm just looking at event Z. That's the only one that I'm looking at. I don't care about the rest of them. So X given Z, event X would be right here. 62 would be my denominator, 63 would be my denominator, and 50 would be my denominator. So X given Z would be 26 out of 62. X given Z would be 42 out of 63. X given Z 24 out of 50. And we want to know which one of those X given Z's, we wrote all the fractions, which one equals 0.48. Okay, so punch that in your calculator. Quickly, 26 divided by 62 is 0.41. Does 0.41 equal 0.48? Nope. Next one, 42 divided by 63, that is 0.66. Does that equal 0.48? Nope. Hopefully it's this next one. Punch that in our calculator. We do get 0.48. So C is my correct answer. On the back side, let's look at the back side really quickly. Over here. All right, a random survey was conducted about gender and hair color. This table records the data. If we look ahead at number 12 and 13, it's going to be a given problem. The only problem is, like when I circle one of these, I normally have the totals right here and over here. I have the totals so that will be my denominator. I don't have those totals right now, so I have to make those totals. I have to add 548 plus 876 plus 82. Punch out my calculator. 1506. 612 plus 716 plus 66. 1394. 548 plus 612. 1160. 876 plus 716. 1592. 82 plus 66. 148. All right, so now I got all my totals. What is the probability that a randomly selected person has blonde hair given that the person selected is female? I'm not looking at everybody. All I'm looking at are the females right here. So my denominator will be 1394. What's the probability the randomly selected person has blonde hair since they're a female? So 716 out of 1394. You could punch out your calculator, and if you got a good one, it will reduce it to 358 over 697 and punch the magic arrows, or you could go from this over here. If you don't have a fancy calculator, that would be 0.51. Okay, let's look at number 13. I've got, what is the probability that a randomly selected person is male given that the person has brown hair? Okay, so we're just looking at brown hair people. 1160. And how many of those are male? 548. That will reduce to 137 out of 290. Magic arrows, 0.47. Okay, either one of those is correct. Next set, we've got some, are these independent events or not? So number 14, which of the following events are independent? Given probably A, probably B, probably A and B. So just before we start, remember we had this probability of A and B equals probability of A times probability of B. So when we multiply the two little ones, I say little ones, probably the two single ones, and we get the one where they're combined, then it's independent. If we don't get that, it's not independent. So looking at 14, we go ahead and mark choice A because they all say A. What type of moron made this worksheet? All right, so I'm gonna check A. I'm gonna say 0.25 times 0.25. It doesn't give me 0.5. Spoiler alert, no, it does not. 0.08 times 0.4. Does it give me 0.12? No, I think it's like 0.032 maybe. So not A, not B. Probability of A, 0.16 times 0.24. Does that equal 0.32? No, it does not. Hopefully it's D. Point A, or probability of A is 0.3. So we got 0.3 times 0.15. Does that equal 0.045? Yes, it does. So answer choice D would be correct. Okay. Number 15. In a certain school, the probability that a student plays a sport is 40%. Probability that a student is a senior is 23%. The probability that plays sport and is a senior is 0.5. So the and, that's going to be my one that goes right here. Okay. So we want the other two to multiply to give me that. I've got 0.4 times 0.23. And does that equal 0.05? When I multiply 0.4 times 0.23, I get 0.092. That does not equal 0.05, not independent. Now the question says, how do you know? I just showed you how I know. Okay, this is you showing work. Okay. All right, last side. We got Terry. He's got a number cube. What's a number cube? It's a die, which is singular for dice, which is one of those things that people roll with all 1, 2, 3, 4, 5, 6 on it. We got a number cube labeled 1 through 6. He rolls the number cube twice. What is the probability that the sum of the two rolls is a prime number, given that at least one of the rolls is a 3? Okay, given that at least one of the rolls is a 3. So I've got, it could be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, or 3, 6. Why not 3, 7? Because there's only 6 sides. All right, we got 1, 3, 2, 3, 3, 3 has already been done, 4, 3, 5, 3, and 6, 3. Okay, so in total, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 ways. And we want a prime number. All right, the sum of the two rows is a prime number. Well, 3 plus 1, these equal 4. 3 plus 2, this is 5. That sum is 6. That sum is 7. That sum is 8. That sum is 9. Prime numbers, numbers that are only divisible by 1 and itself. 5 is a prime number. 7 is a prime number. I think that's it. 1, 2, 3, 4 of them. That's your answer. You could write that as a decimal if you really wanted to. Almost there. Number 17. Johnny has a spinner with spaces labeled 1 through 5. He spins the spinner twice. What is the probability that the sum of the two spins is greater than 7, given that at least one of the rolls is a 4? I guess this should be given at least one of the spins is a 4. A little Control C, Control V right there. All right, so given that at least one of the spins is a 4, I could have 4, 1, 4, 2, 4, 3, 4, 4, and 4, 5. Why did I stop at 4? Why did I go to 4, 6? I did that up here. I went to 6 up there. Reason, there's only 5. Up here, there was 6. Okay. So likewise, if this was spinner 1, this was spinner 2, you know, we could have 1, 4, 2, 4, 3, 4, 4, 4, 5, 4. Okay, so in total, I've got 1, 2, 3, 4, 5, 9 total. And we want the two spins to have a sum greater than 7. Okay, well, the sum of those is a 5. That's a 6, 7, 8, 9. So we want, is 5 greater than 7? No. 6 greater than 7? No. Is 7 greater than 7? No, it's equal to 7. Is 8 greater than 7? Yes. 9 greater than 7? Yes. 1, 2, 3 of them. That's 1/3. Last set. All right, we got to use these 3 sets of numbers here. I'm noticing that B is a set without them labeled, so I need to write even numbers in the interval 6 to 12. Even numbers between 6 and 12 would be 6, 8, 10, and 12. Okay, so A union B, this would be A or B. Remember, this is like, if you have your 2, this would be everything in both of them. So I'm going to write all these 2, 3, 4, 5, 6, 7, and then everything in B that I haven't already written. Haven't written 8, 10, or 12. Okay. Number 19, this would be the intersection of B and C. So this would be the stuff that's found in both of them. Okay, the overlap's not the right word, but the overlap here. All right, so we're looking at B and C. Things, 6 is in both of them, 8 is in both of them, 10 is in both of them. Okay. Number 20, A intersects C. So once again, that's all of that stuff. So A intersects C would be maybe 5, 6, 7 is in both of them. 5, 6, and 7.